In this video, I am going to prove a very important relation. Cp minus Cv is equal to R. It is also called Mayer's relation. ज्ञान विजर्ड में आप सभी लोगों का वेलकम है. मैं हूं अजमल. Cp is the molar heat content at constant pressure and this one is at constant volume. Let's take the first case. We heat a ideal gas of 1 mole at constant volume. That means here piston is fixed. When we will provide heat, then temperature will rise. Then from first law of thermodynamics, heat supply Q is equal to increase in internal energy plus work done. We know that work done W is equal to P delta V. Here heat is supplied at constant volume. Piston is fixed. That means there is no change in volume. The delta V is equal to 0. Therefore, work done W is equal to 0 because delta V is equal to 0. Now we can write this expression Q is equal to delta U. Delta U is the change in internal energy. If we take the incremental heat dQ, then the change in internal energy will be du. Now we know that this dQ is equal to NCV dt. NCV dt is equal to du. Because here we have considered 1 mole. That means N is equal to 1. When N is equal to 1, we can write Cv dt is equal to du. That means incremental increase in internal energy is equal to Cv dt. Let's consider the second case where heat is supplied at constant pressure. That means this piston will move to keep the pressure constant. So from first law, heat supplied Q is equal to change in internal energy plus work done. Let the incremental energy dQ is equal to du plus dW. Here dW will not be 0 because piston is moving, gas is expanding. Now work will be done by the gas on the environment and it is positive. dQ is equal to du plus work done is equal to P dV. Now we know that for ideal gas, PV is equal to nRT. Here we have taken 1 mole of ideal gas, therefore N is equal to 1. That means PV is equal to RT. N is equal to 1 mole. Now let's do the partial differentiation. First function P dV plus second function V and partial differentiation of P. This is equal to R is a constant dt. Now here pressure is constant because here heat is supplied at constant pressure. That means dP is 0. Therefore, this term will be 0. We can write it as P dV is equal to R dt. Internal energy of an ideal gas depends only on temperature. In both the cases here, temperature is same, delta T. Therefore, internal energy will also be same. So we can write that du is equal to NCV dt. We can write here dq, let's first write it here, Cv dt, Cv dt plus P dV. P dV we can write from here as R dt. R dt. dq is at constant pressure for 1 mole. We can write it as Cp dt. dt, dt, dt cancelled out. Now Cp minus, we transpose Cv on the left side, Cp minus Cv is equal to R. This is what we have to prove. This is the Mayer relation. Hope you find this video useful and informative. Please like it, share with your friends, write your comments in comment box and subscribe my channel. Thank you very much for watching this video.